Greetings, this is Derek Ong with video number 7, the continuing series of SMARTPLS usage for structural equation modeling. So, in my preceding videos, I have shown you how to uh, analyze and get out the results for the measurement model. Um, for indicator reliability, convergent reliability, and internal consistency, but I did not cover discriminant validity. So this is video number 7, which will cover this discriminant validity. So discriminant validity basically has two things that you can look at. This is the discriminant validity is also called vertical collinearity here. It is the subjective independence of each indicator on its latent variable. So you want to make sure that your respondents are not confused that your indicator items which you use in your questionnaire actually measures the latent variable that it's supposed to measure, and it's not confused, and you don't have this thing on cross-loading. So what you can do is you can start by looking at the cross-loading criterion, which is the subjective independence that can help reduce the presence of multicollinearity amongst the latent variables. So you can imagine if you have an indicator item that loads on two latent variables, then that particular indicator item is not actually a very good one, denoting that the AVE of a latent variable should be higher than the squared correlations between the latent variables. The alternative approach, which a lot of people have looked at, is the heterotrait monotrait ratio correlations. Yeah, basically, we want to ensure that your heterotrait monotrait, that your latent variables are very discriminant of each other, and that there are no kind of confusion between the latent variables by uh, your respondents. Okay, so we look at HTMT. Of course, the lower the value of the HTMT, the better, which means that uh, if let's say if the null hypothesis test lower values of 1, then it will be good. But if the HTMP has a very close to value of 1 or a very high value of 1, then that means that there is no discriminant validity, and this is not good. Okay. Again, as I said, you can always look at the references as I mentioned here below. If you need to explain about and refer when you're doing your writing. Okay, so I'm just going to be very quickly now to show you where to get all these results. In my preceding video, of course, I have run the PLS algorithm. I have extracted out the information for the table of the first tree. If you remember the items, loadings, AVACR, and row A. So now I'm going to show you how to extract the items for the discriminant validity and the heterotrait monotrait. So go back to the PLS algorithm. Please look at the discriminant validity section on the quality criteria. You notice that this is the Fornell-Larcker criterion. This is what we call the cross-loading criterion. Now, you can have three types. So I'm just going to show you the first one. This is the cross-loading criteria, whereby if you notice that every single one of these cross-loadings must be higher than the on the variables here. So I'm just going to show you this. So copy this into Excel format first. I'm just going to indicate this as cross. Oh no, I can show this to you as discriminant validity. Validity. Okay. I'm just going to delete this. Now, some of you might be asking, is it okay if there's a negative? Of course it's okay, because some items will be negatively loaded. It just means that it's a negative relationship between the items and the latent variables. So I am going to shift my CP1, which is a little bit off here, up here. So it makes a little more sense, right? Okay, and I am going to bold CP1 with with the customer support. So what I'm doing is I'm actually bolding the indicator items that's supposed to be loaded on the latent variables. You notice costs, FP here. You notice the TA, which is technological adoption, TA123, yeah. And then the technological readiness. Technological readiness, which is here. Almost made a boo-boo there. And of course, the TMS 3, 4, and 5. Okay, so what's the first criteria that we want to see? The first criteria of the cross-loading is to ensure that every single late indicator variable loads the highest on the latent variable, whether it is across or vertical. So CP, you notice that all these three is loaded as the highest on the latent variable customer support. Same goes for costs. Same goes for financial performance. Same goes for technological adoption, technological readiness, and as well as TMS. Yeah, technological support. So I am going to copy this whole table and put it here. And notice I'm going to put this as table. Oh, still on the subscript, isn't it? Just keep it at 11 probably. Table. Oh, that's too small, isn't it? 14. Table 2. Indicator items cross-loading. Yeah. Indicator item cross-loading. Which is yeah, I'm gonna paste. There you go. So you notice that each of the items are, or each of the indicator item is used properly on each of the latent variables. So there's no problem in terms of understanding. Okay, the anal part of me is coming in. I think I need to readjust this. This looks better, doesn't it? And of course, you can redistribute, make sure that everything is 3 decimal spaces. So I'm just going to put one more little down here. Okay, so there you go. You have table 3. So that's the first one you need to do for your uh, cross-loading for your items, the indicator variables. Then you also need to do the discriminant validity, the Fornell-Larcker. I'm just going to write here table 3, discriminant validity for Nell and Lark criterion, in which you want to make sure that each of the latent variables are, in fact, um, different from each other, because the indicators must be the highest. Okay, that means each of the latent variables on itself is the what do you call this, the diagonal is the highest in terms of the r square on each latent variable on itself. So Very simple. I just have to copy this Excel format, put into Excel, and paste. Oh, something went wrong, didn't it? Ah, let me do that again. Uh, yeah, yeah, just Excel format. You copy that whole thing and paste. Perfect. And all you need to do is just highlight the diagonals, making sure they're the highest, again across and below. And you notice that this is just going to be a mirror of the lower diagonals. Copy this. So copy this. There you have it. Fornell-Larcker. Yeah, simple and easy. You can have this right here, and you can, well, if you want to, you can put in all the borders, which will look fairly okay, right? Ah, I'm sure all of you will know how to do your own. Um, and also, of course, make sure you write a note here that to say the let's change this to 8. The diagonal, um, oh, I have it here. Diagonals are the square root of the ABE, yeah, of each of the latent variables. SMARTPLS 2, you had to calculate, but thank God for SMARTPLS 3, you don't have to calculate. The diagonals are the square root of the AVE of the latent variables and indicates the highest in any column or row. So that shows there is discriminant validity. Okay, and finally, you need to show heterothread monothread discriminant validity on hetero HTMT if you want to. Past research says that you had to show the 95% confidence interval, and now you don't have to. Yay, that's good news because I remember doing the 95% confidence interval. It was really, really crazy. Anyway, since everything is here, and you notice that nothing is above 1 or close to 1, so phew, that's a good sign. Excel format, paste. I wonder if you can paste it here. Oh no, you can't. Sorry. Might as well just paste it back on here. Uh, do a little bit of niceties. Do you need to change anything? Actually, you don't. Yeah, there's no need to. There is just no need to. Yeah, you don't have to. Because if you notice that all you need to do is just black out these cells, right? Which are the cells that is supposed to be discriminate of each other, but since you've already put on that in terms of the AVE, the square root, you don't have to. Um, if you note that these are the cells which are darkened, uh, it just means that any of these latent variables have low correlation with each other, and that means that there is good discriminant validity. Okay, so I'm just gonna paste that here. Perfect. Uh, again, just put the whole thing. Yeah. So let's take an example. For example, if I were to say there is discriminant validity between customer support and top management support, it shows a correlation of 0.335, which is a very low correlation, which means that these two are definitely two separate latent variables, and that shows good discriminant validity. Okay. Uh, you can put in some uh, information here from sorry, Klein and Gold. These were the two that we wanted to mention about. Um, the CI is optional. You don't have to do the CI because it is not needed in these, right? But doing the heterotrait monotrait is very important for discriminant validity. So, with that, I want to say that you have done everything you need to do for your measurement model. This, the cross-loading for discriminant validity, Fornell-Larcker, and the HTMT. And my next video will cover a little bit else before we move on to the structural model. So thank you for watching.